equations. And biggest thing, remember, absolute value symbol means that you're going to get two answers. So you got to work this thing down to find the two equations we need to solve so we can find those two distinct points. When we get an inequality like this, our answer is going to be an interval. And it's either going to be between the 2 points that you would find like it's an equation, or everything before before the smaller point and everything after the bigger point. We just need to remember which way that goes, okay? So let's start with our equation. So first thing you have to remember with these are a little bit tougher than the ones we started with. You have to isolate the absolute value in every one of them. So that means we've got to get this part by itself in each and every one of these expressions to be able to solve this, okay? So let's go ahead and let's see answers. So I have the answers already written. We are going to do the work, but that way, since you guys have already done it, you can check them. So to get this isolated, we're going to minus this 10. You can do algebra with this just like you would any other equation. And we get 6b minus 2 inside the absolute value is equal to 34. Now that the absolute value is isolated, remember the stuff inside the absolute value. Stuff inside the absolute value can be either positive or negative of that answer. So this is where we split this into two equations and we say 6b minus 2 can give me a positive 34, and that'll be a true statement. Or 6b minus 2 can result in negative 34, and I will get a true statement. And we'll solve both of these. So we're going to go 6b. We're going to add the 2 and get 36. So this is where we get the 6. And we're going to add the 2 to that side. We get negative 32. And I probably should have been better when I typed it because there's an easy common factor in that. That should be 16 over 3, right? But I also don't want to hone in on being nitpicky about the fraction as much as the way that we're solving these at this point. I know you guys can simplify fractions, and even more so with the way that we're assessing things. You know, a lot of our stuff's going to be on the computer. I think you can match your answer, negative 32 divided by 6, just about any form they would put it on the screen, okay? All right, number 2, isolate the numerator. So how do we get rid of the denominator? That's a divide by 4, so we're going to multiply both sides by 4. So when we multiply that 4 to the other side, we get 8. Now we split it into 2. Negative 4 minus 3n equals 8. And negative 4 minus 3n equals negative 8. You can get 8, negative 8 to make that a true statement. So we're going to add this 4 to the other side. And then divide by the negative 3. And that's where the negative 4 comes from. Same operations, just a different number on this side. So we're going to add the 4 to both sides still. And we get negative 4. Divide the negative 3. And that becomes positive because it's negative over a negative. We okay so far? And the only thing with these would just be the complex stuff to get rid of the mess that's adjoining the absolute value on the left side. So let's look at the last one, because the last one's, I don't know if it's necessarily tougher. It's just the way it's written. Now, I did a couple of these in the class stuff that I sent out on Tuesday when we reviewed this. But a lot of times, this number right here gets stuck up in the front. And it's actually adding to everything because that 5 is positive. How do we get rid of that positive 5? We've got to subtract it. And it's just, I think though what's weird about it is we're not used to seeing a +5 written in front of everything. So you got to take that and still do the opposite. So this is 8, 10n minus 2, and 105 minus 5 is 96. And that 8 was positive, so now we'll divide by that 8. And what is 96 divided by 8? Let me double check just so I don't mess it up first thing in the morning. That gives us 12. And then here's our two equations to solve. Negative 10n minus 2 can give me 12. And negative 10n minus 2 can give me negative 12. So solve them separately. Add the 2. And then we divide by that 10. And this is where I got negative 1.4. Okay? Only time I really want you to worry about writing it as a decimal is if you can make it a pretty decimal, something that terminates a couple decimal places, you know, 0.125, stuff like that. If it's 0.3 forever, write it as a fraction. 0.6 forever, write it as a fraction. Leave stuff exact. All right, continuing on, we're going to add 2. We get negative 10. And then negative 10 over negative 10 is where I got the 1. And we seem pretty comfortable with that, which is good. This is just algebra. And the key with this is we're getting this absolute value isolated so we can make 2 equations and just solve them just like we always have. And just remembering that you get 2 answers. It tends to get a little bit goobered up when we come over here and we start dealing with these inequalities. Now, don't pay attention to the answer quite yet. Now, what happens is, because this is an inequality, and you can see this if you went to the graphs, when you make the graph of an absolute value, like this one is over here, like this. If we compare that to a line at y equals 4, when we were finding those 2 answers, we were finding the 2 spots that they touched. When we find this answer, we're actually finding an interval, because what's going to happen is we get this, one of these becomes an inequality. Y is always greater than 4. Okay, because if I plugged in the 2 answers, like if I solved this and I got 1, 1 plus 3 is 4. Absolute value of 4 is 4, right? So that makes that statement true. But if I made that number, if I made x 2, do I also get a true statement? What is 2 plus 3? 2 plus 3 is 5. Is 5 greater than 4? So we get a range of answers, because I could plug in anything bigger than 4 for x, and it's always going to give me an answer that's greater than 4. Because when you look at it graphically, you get this y is greater than 4. It shades up here. And Desmos does a much better job of showing it to you pretty than I do handwriting it on the board, okay? And it actually means that the space on the x from wherever this intersection, this way would be an answer, and this one, this way would be an answer. Now, I gave you some notes to look at with this. What I want you to remember is the way that we're going to start this, the way we're going to do this. You got to remember that the way the inequality opens determines what type of answer set you're going to get. You're always going to be finding 2 answers, 2 numbers. Same way we did in 1 through 3. We just have to figure out whether we're going to shade before and after those numbers or in between those numbers. If the inequality is facing the absolute value, you're going to shade before and after. And then what I want you to do when you think through this, I want you to solve this inequality like it's an equal sign. Oh, and I just wrote it with an equal sign. There we go. Helps with my brain and my hand communicate better. That's where I got these answers, because this is x plus 3 equals 4. And this is x plus 3 equals negative 4. So we're going to minus that 3. There's the 1. And there's the negative 7. So that means my two numbers in my picture up there on my line are negative 1 and, 1 and negative 7. Which one should be further left? The negative 7 or the 1? That's right, the negative 7. Negative 7 comes smaller numbers first, bigger numbers second. Now, the only thing I have left to do before I go through and I write this answer in all three forms is I need to figure out, do I include the endpoints? And that comes down to looking at the actual inequality. I have to kind of say this one out loud. This means the absolute value is greater than 4. There's also one that looks like this. What does that little line underneath it mean? That means equal to. If you don't have the little equal to symbol, then you don't fill in the points that you find. If you do, then you do fill in. I mean, that tells you whether it has the line or not, tells you whether to include the endpoints in this range. Okay? So this is one way to represent that answer. But I'm also going to write it in interval notation. So if we write this in interval notation, we got to go back when we did key features. All the way to the left is negative infinity. And we're going to stop at negative 7. How do we say not included? Rounded bracket or squared? Rounded. This is going to be from 1 to positive infinity. Neither one of those get included. And then we put a u in between them. This interval and that one. This answer in interval notation means the same thing as the picture. The other way you may see this answer represented is with inequalities. I don't like memorizing the inequalities because it's just another thing to memorize. And if I have a bad morning, I'm taking a quiz and I don't remember those, it makes it even tougher. But we can write these things as inequalities. So we've got x, negative 7, x, and 1. We need to put the inequality in between it. So all the numbers that I've shaded, are they less than negative 7 or more than negative 7? Everything on this side, numbers over here will be like negative 8, negative 9. Those are all less than. So x on this side is going to be less than that 7. Everything over here, that's 2, 3, 4, so on and so forth. Those are all numbers. X that we're going to find is actually going to be bigger than that 1. That's the third way you could see this answer written. Because of the nature of how we're doing this right now. Depending on what assessment and what practice you're getting, you could see this written as just inequalities, like this. You can see this written as interval notation. You could see it, the answer written as the line. So we want to practice all three so that we know that they're all the same thing. And that's the key with this. All of these things mean the same thing. They're all three representations of the same interval, practically interval notation and inequalities. Okay? So let's do the last one. Only thing I added to the last one was that we needed to do a little bit of algebra first. Now, before I can determine whether I'm going to be in between the points or before and after them, I need to get the absolute value by itself. Because when you deal with the inequality, there's one thing you've got to remember. If you divide by a negative number, you have to flip the direction of the inequality, which could change the way our answer looks. Okay? So let's do this algebra just like we did before. We're going to minus this 6 to the other side. And that's going to give us 9. Then we're going to divide by 3. So in this one, we said when we're facing the absolute value, that's where we shaded before and after. Is this inequality facing the absolute value? No, it's facing the number. And when it faces the number, that means we're going to have the space in between it this time. We can still go about this just like we did before. Pretend this is an equal sign so we can find the numbers at the end, and then we'll write our answer from that. So this is going to be, this is where I get 1/2 x plus 2 equals 3. And 1/2 x plus 2 equals -3. So 1/2 x is +1. How do you get rid of 1/2? What do I want in front of the x? I don't want it to be a half. I want it to be 1. So what do I need to multiply by? I need to multiply by both sides by 2. So that'll make 1 times 2 is 2. Let me write that step in so we see that. We have to multiply by 2 to get that to cancel, which means I need to do the same thing here. This is our -5. We're going to multiply by 2 again. There's our -10. So it does match the answers that I had there, but I wanted to see how I got them. So let's write this a little further down since this is going to be our answer. So -10 comes before 2. This one's a little easier because the interval notation is there's only one interval notation. We've got -10 to 2. Now, we didn't talk about it. Let's talk about it. Do we include the endpoints this time? Is there a little bar underneath that? Nope. So the endpoints are still open, so they're still not included. So there's our interval notation. Now, writing the inequality can be a little bit trickier but here's what I want you to remember. The yellow line, this stands for x. So right now, x is trapped in between two numbers. So when you write the inequality, x is in the middle this time. It's not on the outsides. And it's trapped between two numbers. What two numbers is it trapped between? -10 and 2. And there we go. We have our 3 sets of answers, okay? Practice. And a lot of this comes down to kind of like when we did rational features, you had to be able to factor really well to get to it, get into those parts. So you had to practice that. Your algebra skills have to be pretty well honed with this. So you may need to practice your algebra skills and look some of those things up. Because like the 1/2 can be confusing. The absolute value on top of a fraction can be a little bit confusing. So that's why I made sure we went over those particular types, because that type of algebra works all the time. All right, one other thing I want to talk about absolute values before we jump to piecewise. There's two other solutions that we can get for this. We can get this as an answer. We can get all real numbers, or we can get no solutions. I may have these backwards. Hold on, let me think. I may have typed this one wrong. So let's look at y. And let's actually do this. Let's flip this negative right here. Let's say we dove straight into this to work on this before, okay, like we normally would. We need to divide that 4 to the other side. So we're going to get 3x minus 1, and we're going to divide by 4. Now, if you go to find the endpoints, we get this, right? Can the absolute value ever output a negative? But our initial reaction to this is to go, well, that means that this is no solutions. So why do I say that this is actually everything? And it comes down to interpreting this symbol. Because when you have an inequality, when you get one that gives you a negative on the outside, you're going to have to look at it and kind of think your way through it real fast. Because the reason this is all real numbers is what it's stating is it doesn't matter what x you put in here, you're always going to get a number that's bigger than -2, because that's what this says, is this absolute value is greater than -2. And why does that work? Because what type of numbers have to come out of an absolute value sign? They always have to be positive. Are positive numbers bigger than negative numbers? So by definition, because there's an absolute value and it's saying that it's going to be bigger than a negative number, that's kind of like, well, yes, that's because it's always positive, and positives are bigger than negatives. So when you get this negative on the outside, you need to look at the inequality. Let's look at why this one is no solutions. Because this one right here is no solution. So let's do our division. Why is this one different? Because that inequality faces the other way towards the number. This one says that our absolute value is going to be smaller than a negative number. What numbers are smaller than -3? -4, -5, stuff like that. We can't get any negatives out of our absolute value. Therefore, there's no way to ever make this true. Absolute value has to be positive, so therefore the absolute value has to be bigger than that negative. So when you get a negative left over on the outside, it's not always no solutions. You get two different types of things. You can be everything if that inequality faces the absolute value, then it's going to be every number because you're always bigger than negative numbers. If it faces the other way, faces the negative number, well, that's a no solutions, because there's no way a positive number is ever going to be less than a negative number.